And let's go to example number 9. Solve the equation 4 cos theta minus 2 sin theta plus 2 is equals to 0 for theta between 0 to 360 degrees inclusive. Now, how do we solve a trigonometric equation with a cosine double angle? So if you have 4 cos 2 theta minus 2 sin theta plus 2 is equals to 0. So to solve that equation, the first thing is to get rid of the double angle, isn't it? The first step is to get rid of that double angle. So the double angle here is cos 2 theta. So cos 2 theta is the same as cos theta plus theta, isn't it? So cos theta plus theta, that is a cosine sum angle formula, isn't it? So a cosine sum angle formula, if you have cos A plus B, that is cos A cos B. If this side is positive, the other side is minus sine A sine B. So it means when you are given cos theta plus theta, then that is where there is A you put theta, where there is B you put theta. So in the end you end up with cos theta minus sin theta, sin theta. So if you work out that cos theta times cos theta is cos squared theta minus sin theta times sin theta is sin squared theta. Then you substitute it back. So it implies that cos 2 theta is the same as cos squared theta minus sin squared theta. Now you go back to your equation and you substitute that cosine double angle, isn't it? So you substitute that cosine double angle. So in our original equation, we were given for cos 2 theta minus 2 sin theta plus 2 is equals to 0. So if you substitute this cosine double angle, we have 4 into cos 2 theta there, then minus 2 sin theta plus 2 is equals to 0. So where there is cos 2 theta, you put the value of cos 2 theta, which is cos squared theta minus sin squared theta, isn't it? Can you see that? So you put that bracket because the whole of it is cos 2 theta. Then after that you open that bracket, a factor outside the bracket multiplies all the factors inside the bracket. So 4 times cos squared theta you get 4. Cos squared theta minus 4 times sin squared theta you get 4 sin squared theta. Then minus 2 sin theta plus 2 is equals to 0. Now that is the first step. We've gotten rid of the double angle, isn't it? Now step 2, you now ensure that you are using a single trigonometric identity. The second step is to ensure you are using a single trigonometric identity. So to ensure you are using a single trigonometric identity is to use the Pythagorean identity, because it is the Pythagorean identity that relates the cos and the sine, isn't it? So you use the Pythagorean identity to eliminate either cos or sine. So if you can look here, the only thing to be eliminated here is cos squared, because you have sine are remaining, isn't it? We have sine squared, we have sine which is not squared, so it means the task is to eliminate cos squared theta, isn't it? So the next step is to use the Pythagorean identity. So in Pythagorean identity, when you have cos squared theta plus sine squared theta is equals to 1, isn't it? That is the Pythagorean identity. So if you make cos squared theta the subject of the formula, we have cos squared theta is 1 minus sine squared theta. So where there is cos squared theta, we are going to put 1 minus sin squared theta. So our equation we have, our equation here we have 4 cos squared theta minus 4 sin squared theta minus 2 sin theta plus 2 is equals to 0, isn't it? So where there is cos squared theta, you substitute the value of cos squared theta, isn't it? So where there is cos square theta, you substitute the value of cos square theta, which is 1 minus sine square theta, then you close that bracket, then minus 4 sine square theta minus 2 sine theta plus 2 is equals to 0. So the next step is to open that bracket. Open that bracket. So 4 times 1 you get 4. Then minus 4 times sine square theta you get 4 sine square theta. Then minus 4 sine square theta. Then minus 2 sine theta. Then plus 2 is equals to 0. So up to that step, we've eliminated the double angle and we've ensured that everything is in terms of one ratio and everything there is in terms of the sine, isn't it? So the next step is to simplify that expression, the whole of that equation. We simplify, meaning we join together the like terms, isn't it? So here we have negative 4 sine square theta and negative 4 sine square theta. That gives you a total of negative 8, isn't it? So there we have negative 8 sine square theta. So we've dealt with negative 4 sine square theta and negative 4 sine square theta, isn't it? Then the next thing we deal with, here we have negative 2 sine theta. So that one follows next, negative 2 sine theta. Then you join the known terms. This is positive 4 and positive 2 gives you a total of positive 6, isn't it? Is equals to 0. So we've simplified that expression. So having simplified that expression, it is in form of a quadratic equation, isn't it? So that is now quadratic. So the quadratic equation, you let sine theta be. So you let sine theta to be x or y, any variable, isn't it? So where there is sine theta, you put x, meaning if you have sine squared, that is x squared, isn't it? So it means this equation will now becomes negative 8x squared, then minus 2x plus 6 is equals to 0. Where there is sine theta, you put x, meaning sine squared theta is x squared, isn't it? So we've reduced the equation back to a quadratic equation. So how do we solve a quadratic equation? The standard form of a quadratic equation is ax squared plus bx plus c is equals to 0. So from here you can see the coefficient a is negative 8, isn't it? Then b is negative 2. Then c is positive 6, which is just 6, isn't it? So if you use the quadratic formula to solve for x, then x is given by negative b plus or minus square root of b squared minus 4ac over 2a. So substitute the value of a, b, and c to get the values of x. So negative b there will have negative of negative 2, that is positive 2, zero. Where there is b, you substitute with negative 2, so we have positive 2 plus or minus, then work out the whole of that root. So square root of b squared, negative 2 squared is positive 4, because both negative and 2, both of them are values of b, meaning both of them are squared, isn't it? So you get 4, then minus 4ac, 4 times a is 4 times negative 8, negative 32 times c, negative 32 times 6. Huh? 190, negative 192, isn't it? So negative into negative is positive, so it is 4 plus 192. So you get the square root of 196, isn't it? So what is the square root of 196? 14. Exactly 14. So the square root of 196 is 14. So we have 2 plus or minus 14 over 2a. What is our a? Our a is negative 8. So 2 times negative 8, 2a will be negative 16, isn't it? Are we together? So from there, what is the first value of x? x1, you block the negative sign in the middle, isn't it? So x1 will be 2 plus 14 divided by negative 16. You get x1 to be negative 1, isn't it? Then the next value of x, x2, you block the positive sign in the middle. So you have 2 minus 14 divided by negative 16, isn't it? So 2 minus 14 is negative 12. Negative 12 divided by negative 16. Positive 0.75. What have you found? 0.75. So x2 is 0.75. So where there is x, you put the value of x. The value of x is sine theta, isn't it? So where there is x, we put sine theta. Where there is x, we put sine theta. So we have sine theta. We have sine theta is equal to negative 1, or sine theta is equal to 0.75. So we start with the first one to get the values of sine theta, isn't it? So let us start with the first one when sine theta is equal to negative 1. Meaning you draw the unit circle. So in your unit circle you have all students take calculus. So from there in the first quadrant, it is just some angle beta. The second quadrant is 180 minus beta. The third quadrant is 180 plus. Then the fourth quadrant is 360 minus beta, isn't it? So sine theta is equal to negative 1. It implies theta is the sine inverse of negative 1. So we get the sine inverse of 1 when negative sign tells you the quadrant. Are you seeing that? Meaning we are looking for the quadrant where sine is negative. Are you seeing that? We look for the sine inverse of 1, but this negative sign tells you the quadrant you are going to look for that, isn't it? So you simply look for sine inverse of 1, but not negative 1. Are we together? The negative sign tells you the quadrant. Are we together? So what is the sine inverse of 1? Sine inverse of 1 is 90 degrees. So it means our angle beta here is 90 degrees. It means 180 minus beta, 180 minus 90 will be 90 degrees. 180 plus 90 will be 270 degrees. Then 360 minus 90 will also be 270. But we want quadrants where sine is negative. We want quadrants where sine is negative. So you start with the first quadrant. The first quadrant, all are positive. So the first quadrant, all are positive, meaning we don't need that first quadrant. So it means that angle in the first quadrant is out, isn't it? Then in the second quadrant, only sine is positive, meaning we don't need the second quadrant because we need where sine is negative. Are you seeing that? In the third quadrant, only tan is positive. So if only tan is positive, it means sine is negative. So we need that angle 270 degrees. Are you seeing that? In the fourth quadrant, only cosine is positive, meaning sine is negative in the fourth quadrant, isn't it? So we need that angle in the fourth quadrant 270 degrees. So it means the solution when sine theta is equal to negative 1, the solution for theta is, the solution of theta is 270 degrees. Are we together? You go to the next. Move to the next. When sine theta is equal to 0.75, what are the solutions? So when sine theta is equal to 0.75, then it implies theta is the sine inverse of 0.75. So 0.75 means positive 0.75, isn't it? So it means we are looking for the quadrants where sine is positive, isn't it? We are looking for the quadrants where sine is positive. So get the sine inverse of 0.75, then you look for the quadrant where sine is positive. So what is the sine inverse of 0.75? Draw the unit circle first of all students take calculus. So first quadrant is beta, second quadrant is 180 minus any angle beta, third quadrant is 180 plus beta, fourth quadrant is 360 minus beta. So can you get me the angle beta? Sine inverse of 0.75? You have 58.6, 48.6. So it means the angle in the first quadrant is 48.6 degrees, isn't it? And the angle in the second quadrant, 180 minus 48.6. 131.4 degrees. 180 plus 48.6 degrees. In the third quadrant, 220.6 degrees. Then the last quadrant, 360 minus 48.6 degrees. You have 311.4 degrees. Then you start. We are looking for the quadrants where the sign is positive. So the first quadrant, all of them are positive, meaning in the first quadrant sign is positive. So we need that angle in the first quadrant, isn't it? Then the second quadrant, only sign is positive. So we need that angle in the second, because we are looking for the quadrants where sign is positive, isn't it? In the third quadrant, only term is positive, meaning sign is negative in the third quadrant. So we don't need that, isn't it? In the fourth quadrant, only cos is positive, meaning sign is negative there. We don't need that. We only need where sign is positive. So it means here in the second case, there are values of theta are 48.6 degrees and 4 degrees. So you end up with the theta, the first one, start with the smallest one, 48.6 degrees, followed by 270 degrees. Then you are told theta is in the range between 0 to 360 degrees. So it means you eliminate any of these angles which is not between 0 to 360 degrees inclusive, isn't it? So you can see 48.6 degrees is between the range required, 270 is between 0 to 360 degrees inclusive, 1.4 is also between 0 to 360 degrees inclusive, meaning all these angles are required according to the range given, isn't it? Meaning the first step is to determine those angles first. After getting all of them is when you eliminate the ones they don't need in the range, isn't it? So it means all those angles are required as per the range we've been given. Are we together? So that is how to solve a trigonometric equation having a double angle. That is how to solve a trigonometric equation with a double angle.